In this video, you'll be learning about F1-score. So let's first look at the issues with the accuracy. Suppose there are 10 events and we have the following true labels and predictions for each event as in the table 1. The model got 9 correct predictions out of 10 events. So in this table, you got prediction 0 and true label 1, 1 wrong answer, and the rest of them all correct. So the accuracy is 9 out of 10 is 0.9. That is, the model is showing the accuracy of 90%. 90% of accuracy seems quite good though. What do you think? Can you argue that your model is good? Not really, because the accuracy is giving us the biased information. In the previous slide, we had 2 true events denoted as 1 and 8 false events denoted as 0 out of 10 events in total. The problem is that the distribution of the examples is not balanced. Now suppose we have balanced distributions of examples with 5 true events and 5 false events as in the right table 2. Although the model predicted one event as true and the rest of 9 events as false as in earlier slide, it got 6 correct answers out of 10 events, that is 6 out of 10 is 0.6, which is 6% accuracy. So this is correct, and 1, 2, 3, 4, 5, 6, and these events got wrong predictions. If the models, so in this case, the accuracy is 60%. If the model performance is poor in balanced distribution, we call the model is not skilled. So even though the prediction is the same distribution as in the earlier slide, and when the distribution of examples gets balanced, the model becomes performance becomes poor. So thus we don't know if the model is skilled with given accuracy when the distribution of examples are imbalanced. An alternative measure is F1-score, which gives information about whether the distribution of examples are not balanced for the given accuracy. The F1-score is defined as F1-score is 2 times precision times recall over precision plus recall. In the following video, I'm going to explain about precision and recall, and even if you don't not know about above formula, you can use sklearn to measure the performance of your trained model in F1-score. So I'll show you example of a F1-score using scikit-learn. So here you call the API F1-score from scikit-learn.metrics, and you can see more details in their official website, and I'm going to put the link under my video in the show more box. And the accuracy is defined as with 2 parameters, true labels and predictions, and the number of correct is set to 0, and total number of events is the length of true labels, and you loop, and then whenever the answer predicted label is equal to the true label, then you increment the number of correct by 1, and you return the sum of the n number of correct answers over the number of total. And here we have true labels imbalanced in imbalanced distribution to 1 true events and 8 events with false answers. And down there, true labels in balanced distribution, we have 5 events with true answers and the rest 5 events with false labels. And the prediction, we have 9 false predictions and one true prediction. So in this imbalanced example, let's calculate the accuracy by calling the function getAccuracy and pass the argument true labels imbalanced and predictions. And you also calculate F1 score using the F1-score API by passing true labels imbalanced and predictions. And we'll print out the accuracy and the F1 score. And we are gonna also see the result in balanced example. This time you get the accuracy with the true labels balanced in balanced distribution with given predictions, and F1 score with true labels in balanced prediction in balanced distribution and with predictions. So let's run the file name is f1test.py and it resides in my C# and demo folder, and Python F1 test, and let's wait a bit. So in the imbalanced example, we got 9 correct answers prediction. You have 1 wrong and correct and correct. So accuracy 90%. And F1C it's 66.66%. So even though the accuracy is high, when we see the F1 score, you see low F1 score. So it means that the distribution of the events are imbalanced. So we are not sure whether the model is scaled. So to see if the model is scaled, we must test it in balanced distribution. So in balanced example, accuracy 60%, and the predictions because it got 6 correct answers, and even in this situation, the predictions it's not getting many correct answers. So the F1 score, you can get high F1 score if and only if the events are balanced with many correct answers. So let's change the number, the predictions as 1, 1, 1, and in this case, the labels are balanced and predictions. You get 9 correct answers and 1 wrong answer. So this time, both the events are balanced and the predictions is you get the high accuracy in balanced distribution. So in this case, you will get high F1 score. So let's run again and let's see the result. So as you can see, in balanced example, accuracy is high, and you also get high F1 score, different from the imbalanced example as in the earlier example, which get accuracy 90% but low F1 score. So up to here, I've shown you about F1 score, and so it is desirable to always measure your model's performance both in accuracy and in F1 score to show that your model's performance can do well even in balanced um, even in balanced distribution of events, and that your model is skilled. And sometimes when you evaluate your model on benchmark dataset, and the benchmark dataset may provide imbalanced train and test set, then in that case, you can adjust the weights because you don't want to be too negative about your model. So if you set weighted, average weighted, um, average is weighted, and here, down here, weighted, average to weighted. So run again. F1 weight. Here's wrong spelling mistake. So let's run again. In now it's showing higher F1 score, and the gap between F1 score and the accuracy is low. So if you want to lower the gap between accuracy and F1 score, then you may use average weighted. So this is the end of my video. Thanks for listening. Goodbye.